Hello, math students. We're going to spend another day talking about multiple transformations. And today, not just us doing those transformations, but also being able to recognize what those transformations are. So if you take a look at this slide, we've got three different triangles here. And again, make sure that you're noticing the prime notation. So the red triangle doesn't have any primes. That's my original, my pre-image. And the blue one has one prime, and then the green one has a double prime. So what I want to do here is I want to figure out how I can get from the red to the green using that blue one as the in-between step. So as I'm looking at this, without even looking at the tables and all that stuff that's on here, I want you to notice that to go, for instance, from B to B prime, it's going over the y-axis, and so did A to A prime. And C actually stayed right in the same place. So that to me is telling me that we have a reflection over the y-axis, right? And if you look at these ordered pairs, remember a reflection over the y-axis does this. It takes an ordered pair, and since it's going over the y-axis, the x changes signs. So it'll be on the opposite of x, and then the y. And that's what happened here. I had a negative 3, 2, and then I've got a positive 3, 2. Same thing with the negative 2, 4 to a positive 2, 4. Now the C doesn't change because 0 doesn't have a negative. It's just going to stay that same thing. So the x coordinates are opposites, which means that we are reflecting across the y-axis. Then for the next one, to go from the blue triangle to the green triangle, that's not a rotation. I want you to notice that the B prime and the B double prime, both on the top of the triangle. So this looks like it's just being kind of slid down there. I'm going to move this up just a little bit, which means, oh, and some of my boxes are not quite lined up, that this is a translation, right? As I'm looking at my, let's just stick with the B since it's on the top. My B prime, it's going to move over 1, 2, 3 to the right, which means that I'm adding 3, and that does make sense. 3 to 6, add 3. Here I'm going to add 3. Here I'm going to add 3. So the x coordinates are going to increase by 3. And then the y coordinates, because it's moving down, that's going to move down 1, 2, 3, 4. And if I look at my y's, to go from 2 to negative 2, that is decreasing by 4. 4 to 0 is decreasing by 4. 1 to negative 3 is decreasing by 4. So that means that I've got a translation. It is a congruent translation since all of these were the same. And I'm moving to the right 3 and down 4, which means x plus 3, or y minus 4. All of those shapes are congruent, so we don't have any dilations in this one. This one, clearly the rectangles are not all the same size, which means I can tell right now that I've got a similarity going on. We're going to have a dilation. And again, we're going from A to A prime first, the red to the blue. And if you look at the ordered pairs, some people are better at looking at the ordered pairs and thinking about the rules, and some people are better at looking at the graphs. Looking at the ordered pairs, you can see that for A to A prime, I am changing the sign of my original x, and I'm changing the order, right? Or you could look here and see that, for instance, let's use A. To go from A to A prime, it's going 90 degrees clockwise. And all of the points are doing that, right? They're all moving in the same way. So this is going to be a 90-degree clockwise rotation. Once I know that, I've got my blue, now the single prime, and I want to go to the double prime, the greens. Look at the numbers in the ordered pairs. Again, you can be looking at the graph as well, but to go from negative 2, 3 to negative 4, 6, those numbers double. And that happens in all of these ordered pairs. Everything is doubling. And if you use my trick with checking to see if it's a dilation or not, to go through the origin, there's D prime and D double prime. There's A prime and double prime. There's B and C, and they all line up. That means it is a dilation, and everything got multiplied by 2, so it's going to be an enlargement, and our scale factor is going to be 2 for this. And again, just like we said at the beginning, they're similar, not congruent on that one. Now, looking at these two, without showing all of that work, we just want to figure out how to get from the first shape, which doesn't have any primes, the pre-image, to the final image. And if I look at number 1, I have, make sure that you're going from the red one to the blue one, right? Don't try to go from the red to the green. That's too hard to do right now. This one is going to say, I've got this AD is my long segment, and it's on the bottom here, but it's on the top here. If I look at A is going from here over to there. We're going from quadrant 2 into quadrant 4. This is going to be a 180-degree rotation. And since it's 180, I don't care if it's clockwise or counterclockwise. So we have a 180-degree rotation to go from the original, the pre-image, to the first image, and then to go from the first image to the second image. Now this is not a reflection. I know that it's going from quadrant 4 into quadrant 1, but notice that C prime, B prime, and C double prime, B double prime, both on the bottom. This is a translation. These are just moving straight up. It's not even going to go sideways. So we're going to have a translation. And my translation notation is going to be, I'm going to take every ordered pair. The X isn't going to change because it didn't go sideways at all. But it's going to move up. 1, 2, 3, 4, 5. Every point is moving up 5. In the second problem, to go from the red pre-image to the first image, the blue one, it's getting smaller. That should be a red flag that that's going to be a dilation. And it is getting smaller. So we know that it's a reduction, but we can just tell what the scale factor is as our specific information. To go from A to A prime, this is at -2, 2. And this is at -1, 1. And you can check all these other ones. Everything's getting cut in half. Everything is closer to the origin, and we are multiplying by 1/2. That's what our scale factor is. Then to go from the blue image to the green image, the first prime to the second prime. Now you can see that this is flipping. The B prime is on the top. The B double prime is on the bottom. This is going to reflect over, that's going over this, over the x-axis. In number 3, this is where it gets more difficult. And if you struggle with this, please don't worry, because I'm not going to have any questions like this on the test. This is more of a problem-solving kind of thing. It's not showing the blue image. It's not showing the in-between image on this one. So for number 3, we're going to have clearly a reflection at some point, because the A, for instance, stays on the left side and the D stays on the right side, but AD goes from the bottom to the top for that A prime D prime. So that means that we're going to have a reflection, and it's changing size. So that means that we're going to have a dilation. So if we would reflect over the x-axis, that would, let me just use the blue, that would put C prime right here, and D prime is 2 below the x-axis, so D prime is going to be up here. A is going to be here, and B will be right there, so 1 below. And then we can just take one ordered pair and figure out what's going on. Let's take a look at D prime. D prime right now is at 1, 2, and D double prime is at 2, 4. So that is telling me that everything is getting doubled. Our scale factor is 2. So we're going to have a dilation, and my scale factor is going to be 2. Okay, for number 4, and again, this one is tricky. So if you're struggling to figure this one out on your own, that's okay. I do want you to notice, for instance, that the B starts at the top, and in the B double prime, it's at the bottom. However, it's not a rotation because the A stays on the left and the C stays on the right. So we're going to reflect this, it looks like, over the x-axis. And these are all going to overlap, so it's going to be kind of confusing here. But B prime would be 2 below. C prime is going to stay right where that is because it's on the axis. A prime, instead of being 1 above the x-axis, will be 1 below. And D prime will go 1 above. So if we can look at this shape now, and we want to get it to the green shape, all we need to do is just slide it over 2 to the right. So this is going to be a translation. And my translation notation is going to say that I am going to not change my y's at all, but my x's are going to be moving 2 to the right, which is addition. So x plus 2, and then the y stays the same. Now, that's all of the slides that I have. I don't have a separate slide that tells you what your homework is today. The homework today is to finish up the worksheet from yesterday. Some of the multiple transformations, and then some of the problems where you have to try to figure out what was happening for the multiple transformations. There's going to be a formative, so make sure that you're ready for that, and let me know if you have any questions.